Here's a JPSS satellite that Juan Carlos here helped design. He's a mechanical engineer working in the aerospace industry. He actually designs and builds mechanical parts that go up on the satellite to Mars. Today we're here to talk to him about design thinking and the current project he's working on one of the Mars Rover. So just a quick recap. Design thinking is identify the problem. Number 2, identify your resources. 3, create a plan. 4, execute on that plan. And 5, assess. So show us what you're working on.
This is a project I worked on a few years back, which was requested by a scientist at JPL. He is an astrobiologist and is developing the tooling needed for a Mars mission. When they go to Mars, basically go sample soil and bring in those samples and create a mechanism that can take several samples, introduce different liquids to those samples, process those samples by medium of heat and pressure to dissolve the soils and extract the fluid out of the sample.
So actually the guy who identifies the problem is a researcher who applies to NASA for funding to get his problem resolved.
He said, well, I would like to process samples, but however, that's very vague, so we have to define the problem, and we had to define his requirements, and we had to repeat those requirements to him so that we understood what was it that he was asking for, and so that he understood what was it that we could deliver on. So this is the result of that initial effort.
In the context of future astrobiology missions, the development of chemical detection schemes has progressed to where many are at TRL-6. However, the sample processing systems necessary to provide a conduit between sample acquisition and analysis has lagged in development. To bridge this gap, we have developed an automated sample processing system, or ASPS, that will act as the front end to analytical instruments capable of detecting low concentrations of biologically relevant molecules.
Alright, so basically we've defined the problem, which is a pretty long process, really articulated exactly what resources and requirements there are, created a plan, executed on the plan, and built this prototype, and then step 5 is testing. So what do you do when this whole prototype was done?
So once the prototype was done, we delivered it to the customer so he could take it to the Mojave Desert in California and incorporate it with a little rover and go actually test it in the field and find out how efficient or what does it lack or need. Now, part of developing the solution was a back and forth set of conversations trying to determine and making sure that we were going in the right direction for this answer, for this result.
Juan Carlos, mechanical engineer working in aerospace at Ball.